So the lower airways divides at the carina. That's important to us where it divides. And then it divides into even smaller bronchi. And then it keeps dividing until we have a bunch of alveoli. Now the alveoli, you know, it's like ingenious how biology made us, because the surface area is so huge. You think, like, looking at me right now, like, well, he takes a breath in, that doesn't seem like a lot. But the biology behind it is pretty awesome. And the way these little alveoli are all situated, it increases the surface area so that there's more potential for oxygen to make that diffusion, that journey from the alveoli into the bloodstream on a consistent basis. We just talked about this now. The lining of the lungs, remember we have the visceral pleura and the parietal pleura. And in between there's a potential space, isn't it? And sometimes air gets in that potential space, and what do we call that? A pneumothorax. Exactly. And that could be a bad thing. Now, do all pneumothorax need to be decompressed and stuff? No. Not all of them. You don't know how many times people do it just to do it, though. So, and then we've got the alveoli. We have millions of these little things in there. Millions of them. That's just tons of surface area for us to utilize. And it's lined with surfactant. Now, do you do the dive team, Kevin? No?
I have, but not right now.
Now, like with our drownings, we have an issue with the washing off of surfactant. So if you have somebody who drowns, that could be an issue. Because surfactant, the job of surfactant is to help keep those alveoli open. They're causing some tension in there. Helps keep them open. And if they collapse, are they usable?
No.
No, we need them to be open. Sometimes they do collapse, though. When do you think your alveoli collapse? Happens on a daily basis. When you sleep. They're not needed. Atelectasis. Now, heard that term? Yeah, the alveoli, they just collapse because you're not needed. You're sleeping, right? So they're not needed. And then when you wake up, what do? A big old yawn and stretch. What are you doing?
Filling them up.
You're filling them up. Getting that big deep breath in. Whenever a baby's born, that first deep breath does several things, right? The alveoli are full of what? There you go, amniotic fluid. So that deep breath does what to it? Pushes it out and into the vascular system, and that helps the baby do what also? So the pressure, fluid, right? Clears the airway so they can breathe. That big deep breath also helps close off all the little pathways in the heart that are open. We'll learn about that later. So, physiology of breathing. The respiratory and cardiovascular systems work together. So if we have a problem with one, we should be doing what? Checking the other. Because could a cardiovascular problem be causing the respiratory problem? And could the respiratory problem be causing the cardiovascular problem? Yes, they work hand in hand. If you're hypoxic for some reason, what's your heart going to do? It's going to speed up, right? Initially, for an adult, if you're a child, what's it going to do? It's going to slow down. But as it goes on for adults, what starts happening? It starts slowing down, right? So if you see somebody who's bradycardic, especially a child, you should be going to what pretty quickly? Respiratory. Exactly. That's why when we have a child and we're doing CPR, we find a child that's down, we want to do what first before we call 911? Yeah, you start CPR. Do CPR, get airway, because it's respiratory in nature. But get that going, we might be able to get them back quickly. So the respiratory system provides a constant supply of oxygen and nutrients. that's the respiratory and cardiovascular system, to every cell in the body and removes carbon dioxide waste products from every cell in the body. Now, does respiration and ventilation, are we removing waste products? Yeah, we are. We see that whenever you eat like some weird foods, right? Because what does your breath do? Smells. And that breath, that stinky, that's not because of something in your mouth. It's because of what's in your bloodstream. An example is alcohol. No matter how much somebody with alcohol brushes their teeth, right? If you are DUI and you get pulled over, it doesn't matter if you put mouthwash in or Listerine in your mouth or chew gum. When you blow in that tube, what's going to happen?
It's going to show up.
It's going to show. Because your body's trying to eliminate it. Diabetics. Their blood sugar is 500. Their breath and stink. Because their body's trying to eliminate it. Exactly. So here we kind of talked about ventilation. This is the act of getting air in and out. And this is something that we have to ensure is being done adequately. Now, can we do anything about respiration? There are some things we might be able to do. If their blood pressure is extremely low, we can start IV and get their blood pressure up, right? That would help respiration, right? Cellular respiration, because now we're ensuring circulation. If they're bleeding profusely, we stop the bleeding and we're saving red blood cells from spilling into the ground. That can help, right? There are some things, but one of the first things we need to do is make sure that they're ventilating properly. Ventilation is very important. So you're not getting air, if the active air isn't going in and out, it's just not going to diffuse from the air, right? We're not a frog. Some frogs can, they have that ability. So inhalation. Inhalation is active. Whenever we take a breath in, that's actually a muscular act. When we take a breath in, the muscles, the diaphragm is flexing, right? And the rib muscles, the muscles between our ribs, are spreading the ribs apart, and our ribs cage opens up. And that pressure, a negative pressure, sucks the air in, right? Our air comes in. And then when it's all over with, exhalation just happens. It's passive. So we got this term here, tidal volume. Very important. What is tidal volume?
Normal inhale and exhale.
There you go. It's the amount of air that we're inhaling, right? And that's important because we need to have an adequate amount of tidal volume coming into our lungs. If it's inadequate, is respiration going to occur?
No.
Not effectively. In dead space, this is another important term, the dead space. Whenever you take a breath in, all that air is not utilized. There's these dead spaces. Where are the dead spaces located? Trachea in the mouth there you go. There's no alveoli there. No exchange happens in those areas. The exchange only happens in the alveoli. Minute volume, this is the amount of air moved through the lungs in 1 minute. So tidal volume minus dead space times respiration rate equals your minute volume. How much air is going in, and we don't count the dead space. And vital capacity is the amount of air that can be expelled from the lungs after a deep breath. But every bit of that's not used. Only a portion of it's used. You know, like whenever we take a breath in, the amount of oxygen that's in this room in the atmosphere is typically how much? 21%. However, by the time it gets into our lower airways, that's actually only like 14% in there. But still, that's plenty for the exchange to take place. And the reason why it's only actually around 14% is because of
Dead space.
Dead space. Because not only is there dead space there, but not when we exhale, does everything come out? No. Still some stays in there. Here we go. Residual volume is air that remains after the maximum expiration. And that air still has some carbon dioxide in it, because typically what air is going to come out first when you exhale?
Really came in last.
Which is typically taken up by what? The dead space. If you think about, look at your anatomy. If you're standing in line, the last person to get in is probably the first person to get out, right? Same thing. Same principle there. About 1,200 milliliters remains in an average male. However, our typical ventilation, like if you use an ambu bag to ventilate somebody, how many milliliters is that typically? Can be 5 to, whenever you squeeze the bag, actually it can hold up to 1,000, but anywhere from 500 to 800, depending on how well you squeeze it, is going in. So.